Hi my dear students, welcome to ACE Engineering Academy, ACE Online pre-recorded classes. It's a very good news for you that ACE Online launched pre-recorded classes for B.Tech students, and the name of the program is Campus Edge. Who are teaching these B.Tech subjects? ACE Engineering Academy faculty are teaching these B.Tech subjects. As a part of this program, I am dealing digital signal processing subject. Myself, S.Sreekanth, faculty in ACE Engineering Academy, I am having 13 years of teaching experience in ACE Engineering Academy. Utmost care is taken while preparing the content of this subject. We have gone through the syllabus of several state and deemed universities and finally come across with a unique syllabus. Now let us see what is the syllabus I have covered in this course. The complete syllabus I have divided into 5 chapters, and the chapter 1 is Introduction to DSP and Jet Transform, chapter 2 DFT, Discrete Fourier Transform, DFS, Discrete Fourier Series, and FFT, Fast Fourier Transform, and the chapter 3 is IIR Digital Filters, and the chapter 4 is FIR Digital Filters, and chapter 5 Realization of Digital Filters and Multi-Rate Digital Signal Processing. So this is the complete 5 chapters I have covered in this course. Now let us see what I have covered chapter wise. See students, this is the chapter 1. Chapter 1, Introduction to DSP and Jet Transform. Here I am not discussing the entire content what I have covered, just I am giving an idea, only the outline of the contents what I have covered. See, the first topic I have covered, discrete time signal representation, and the next one, standard discrete time signals, and the next one, operations on discrete time signals. Next one, classification of signals. What are the classifications? Energy and power signals, periodic and non-periodic signals, even and odd signals, causal and non-causal signals. And the next one, classification of systems, linear and non-linear systems, time variant and time invariant systems, causal and non-causal systems, static and dynamic systems, stable and unstable systems. Once again I am telling, only I am giving the outline of the concepts. Again in these topics, subtopics are available. Again in the subtopics are present. And the next topic I have covered in the Introduction to DSP part is discrete time LTS system. Here I have discussed about convolution properties and causality and stability conditions. And the next one, time response analysis of discrete time LTS systems. Here I have discussed natural response, forced response and total response. Next, discrete time Fourier transform, DTFT. Here I have discussed the DTFT of standard signals, and later I have discussed the properties of DTFT. And the next one, solved problems, and the next one, solved several state and deemed universities previous years questions. See students, here after explanation of the every concept, I have solved problems related to that topic. In addition to that, I have solved several state and deemed universities previous years questions related to that concept. It is a very important one. Why? Because in the semester exams, you may get few previous years questions. So for that reason, I have covered, after completing the explanation of the every topic, I have covered several state and deemed universities questions related to that topic. Okay students? Yes. Next, these are all related to Introduction to DSP part. Now, Jet Transform. What are the topics I have covered in the Jet Transform? Introduction to Jet Transform, properties of Jet Transform, inverse Jet Transform, and solved problems, solved several state and deemed universities previous years questions. These two I have included for every topic, solved problems and solved several state and deemed universities previous years questions. Next, chapter 2, DFT, DFS and FFT. So what are the topics I have covered under DFT? See here, concept of DFT, properties of DFT, circular convolution, 3 methods I have covered, matrix method, concentric circle method and DFT IDFT method. filtering of long duration sequences, overlap add method, overlap saved method, and solved problems and solved several state and deemed universities previous years questions. These are come under DFT. And DFS, discrete Fourier series. Concept of DFS, properties of DFS, and solved problems, solved several state and deemed universities previous years questions. Next, the topics under FFT topic are, see here, concept of FFT and DIT FFT, decimation in time, fast Fourier transform, and DIF FFT, decimation in frequency, fast Fourier transform algorithms for calculating DFT. And the next one, DIT FFT and DIF FFT algorithms for calculating IDFT. Here I have covered both 4 point, 8 point as well as 16 point. Okay? Yes. And the next solved problems, next solved several state and deemed universities previous years questions. Next, chapter 3, IIR digital filters. What are the topics I have covered? Steps to design IIR digital filters, Butterworth digital filters. Next one is Chebyshev digital filters, and the next one is analog to digital frequency transformation techniques. In this topic I have covered approximation of derivatives, impulse invariant method and bilinear transformation method. And the next one, design of IIR digital filters. Next, solved problems, solved several state and deemed universities previous years questions. And the next chapter, chapter 4, FIR digital filters. See the topics I have covered: linear phase FIR filters, next frequency response of linear phase FIR filters, next design of FIR filters, solved problems and solved several state and deemed universities previous years questions. These are the topics I have covered in FIR digital filters. And the next chapter, realization of digital filters and multi-rate digital signal processing. First let us see realization of digital filters. What I have covered: IIR filter realization structures, FIR filter realization structures, and next system function, and the next is solution of difference equations of digital filters. Next, solved problems, solved several state and deemed universities previous years questions. These are the topics I have covered in realization of digital filters chapter. And the next one, multi-rate digital signal processing. What are the topics I have covered? Decimation, interpolation and I by D sampling, solved problems and solved several state and deemed universities previous years questions. So these are the outline of the topics what I have covered chapter wise. Once again I am telling, in these topics, subtopics are there. Again in this subtopics are present. Okay? Yes. So these are the complete analysis of 5 chapters. And the next one, how I have organized my lectures in this course. See the first one, concepts are started from basics. If we take any concept, I have started from root level, basics onwards I have started. Let us take for example, realization of digital filters topic. I have not started this topic directly. First of all, I have explained what are the ways to realize digital filters, and second, I have explained what are the elements required to realize digital filters, and the third one, I have explained the operation of each and every element with examples. If you perfect in these 3 basics, you can easily understand the realization of digital filters topic. So like that, for every concept, I have started from basics. If you are perfect in basics, you can easily understand the concept. So same procedure I have applied for every concept. So concepts are started from basics. And the next one, detailed explanation of all the concepts with numerous solved problems by covering all the types of models. See, digital signal processing subject is a problematic subject. So to understand this subject properly, you need to practice more number of problems. So for that, what I did is, after completing the concept, I have solved numerous amount of various types of models of problems for every topic. So after practicing all these type of problems, you will get more confident on the topic and you can able to solve any problem. I have solved concept related examples and also solved several state and deemed universities problems. After completing all this, you will get more confident on that subject and you can able to solve any problem in the exam. And the next very important thing I have added in the lectures is review points at the end of the every chapter. So after completing the chapter, I have added a separate clip that review points. What these review points contain is whatever the important points I have covered in the chapter and what are the important formulas, all those I have included in the review points. I have added a separate clip at the end of the every chapter. Okay? Yes. And the next one is very important one. Solved several state and deemed universities previous year's questions at the end of the concept or chapter. It is heart of the course because in the semester exams, there is a chance that you may get few previous year's questions in the exam. Okay? Yes. That's why after completing every concept or chapter, I have solved several state and deemed universities previous year's questions. Let us see few sample videos on the several state and deemed universities previous year's questions. I have covered all types of models in several state and deemed universities previous year's questions, like short answer questions, long answer questions and theoretical questions. For theoretical questions also, I have given the detailed solution what you have to write in the exam. What is U of n definition? 1 for n greater than or equal to 0. Yes or not? Yes. This is, what is the length of this? Tell me, 4. So, capital M equal to 4. Okay, students? Yes. And we have to choose the value of capital L. I already given this point, capital L value 8. So, you have to pad zeros to the right side such that the sequence length is going to be 8. Now, this is the sequence 2 1 2 1 0 0 0 0. Is asking to apply DIFFT algorithm. Okay, yes. Let us see now. So, the sequence is 20 dB. Okay, yes. This is stop band frequency omega S. This is pass band frequency omega P. Okay, yes. So, omega P equal to 200 radians per second and omega integration minus pi to pi HD of e to the power of j omega e to the power of j omega n into d omega. By using this formula, calculate HD of n. So, now my case one is, it is not multiplied. Explain the concepts with the help of animations for better understanding. So, I have explained the concepts with the help of animations. So, by using these animations, you can understand the concepts in a better manner. Okay? Let us see some of the sample animations what I have used in this course. Right sided signal is out of the outermost circle. ROC of right sided signal is out of the outermost circle. If you see, t is equals to 0 first. Okay, t is equals to 0. When t is equals to 0, a sample from a t is equals to 0, sampler is going to close the switch. Then a sample at the resultant quantity is d of t, capital X of k. See here, how many number of samples are there in this? Capital N number of samples are there. What is the nature of d of t? Discrete and periodic function with period of capital. At minus 4, 1 is repeated at minus 3, 2 is repeated at minus 2, 3 is repeated at minus 1. So, it is a periodic extension extending from minus infinity to plus infinity. Now, for this periodic sequence, next includes a separate video on how to use scientific calculator for problem solving. It is a very important thing for digital signal processing subject because usage of scientific calculator effectively is very important in digital signal processing subject. That's why I have included a separate video on how to use scientific calculator. Let us give one example. See students here. Let us see one question. For the given system, find the frequency response and draw the magnitude and phase response. So what actually we are doing in the problem? First we are finding frequency response of the system and we have to calculate magnitude and phase response for different values of frequency. So we are substituting different values of frequency in the frequency response expression and we are calculating magnitude and phase. If you do it without calculator, it will take 1 hour to 1.5 hour time. If you use the same problem, if you solve the same problem by using scientific calculator, within 5 to 10 minutes, you can solve the problem. In the scientific calculator, there is a function is available, CALC, calc. By using this calc function, you can able to solve this type of problems within a less time. That's why I have included a separate video on how to use scientific calculator. What are the functions which are useful to our subject? All that functions I have explained clearly with the examples. After seeing these videos, you can easily understand and you can easily use scientific calculator for problem solving in our subject. So let us see some of the sample videos on how to use scientific calculator for problem solving. Okay students, how to use scientific calculator for problem solving. How to use calc function. Okay students, first we need to type the expression. What is the expression we have to type? 1 plus 2 cos omega plus 2 cos 2 omega. But omega is a symbol which is not available in the calculator. So instead of omega, type A. Now see students here, 1 plus 2 cos omega, nothing but 2 into cos. To calculate angle value in radian mode, you have to change your calculator to radian mode. Now I want to calculate the angle value to degree mode. That's why I am changing the calculator to degree mode. See students, here shift menu, angle input once again. See here, press 2. I want to calculate the angle in degree mode. So degree mode is cos of pi by 4. Shift pi divided by 4, bracket close, and minus j into means minus I. Here I is available, I into sin pi by 4. Let us see now. One more value will calculate 3 plus j5 into 7 minus j5. See students, 3 plus j5. I into 5, bracket close, into 7 minus j5. 7 log. Here also base 10. How much is there in the inside? Tell me. 600 by 200. Yes, 600 divided by 200. Okay, yes. Entire expression is typed now. Press equal to. Yes. How much I am getting? 1.912. Yes, in a single step I have calculated this expression. This is useful in your Chebyshev filter calculations. Okay students? Yes. This type of expressions you are going to get in both Butterworth filter and Chebyshev filter. Next, how to subscribe digital signal processing course. This course is available in PC, laptop and mobile versions. In the mobile, both Android and iOS applications available. So first of all, you need to download ACE Online application. So this is the ACE Online application. After downloading the ACE Online application, do register. So for registration, first enter your mobile number. After that you will get OTP, enter that OTP. After that you need to fill some basic details. So that completes the registration process. After registration process, you will get an environment like this. So here you need to go to the store. In the store, list of courses are available. In the list of courses are available. So our course is Campus Edge B.Tech subjects. Here it is available. So all these B.Tech subjects are available here. Campus Edge B.Tech subjects. Just to click on this Campus Edge B.Tech subjects. Here list of subjects are available. So the list of the subjects are available. Here digital signal processing, B.Tech digital signal processing. Just to click on this course and you can buy this course. So presently for 6 months the fee is 1500 rupees. So in this way you can buy the course. And the next thing, very important one is while watching the video, if we get any query, we'll resolve that queries within a minute of time. How, sir? See here, just you see this symbol, okay? This is the symbol for ask an expert. Ask an expert. Whenever you are watching the video, this symbol is available on the screen itself. Just to click on that symbol, you will get an environment like this. So here, you can type your query as a text message, or you can attach your query as an image also, okay? Yes. After imaging, just to send this query, then the concerned query will be forwarded to concerned faculty immediately, and the concerned faculty will respond to your queries within a minute of time, within a minute of time. So no need to worry if you get any queries, we'll resolve your queries within a minute of time. Okay? Yes. I hope you will enjoy my lectures. Thank you for watching the video. Thank you.